Okay, yeah, briefly to myself, I'm a product specialist at Esri, working mainly in the domain of real-time and big data GIS, and also what we call GeoAI, which is basically the application of machine learning and deep learning algorithms to spatial questions. And from the real-time and big data domain, I'm working a lot in the context of IoT, so also integrating a lot of sensor data into our GIS platform, and that's why I'm happy to have the opportunity to talk to you about this topic here over the next few minutes. Okay, let's see if the presentation works. Yep, that looks good. So for the introduction, I originally planned to use one of these nice Zoom virtual backgrounds, which I unfortunately cannot hear in the app. So I just put them in the slides. Because for the intro, I stole a few slides from this guy. And for those of you who don't know him, this is Jack Dangerman, the founder of Esri. And he usually has or on the plenary of our annual user conference, he also speaks about the vision of GIS and how the GIS is developing and can be used to solve all kinds of problems in the world. So he has, yeah, it's kind of the vision part is really inspiring. So if you haven't seen it yet, I can only recommend watching the vision part of one of the Esri UC plenaries from Jack. It's up on YouTube. You can find it easily there. But anyways, I stole a few slides for this introduction, and not to kind of repeat what Jack is saying about our vision, because I couldn't, do it as well as he can with my own words, but more so to highlight the importance of sensor data. Because if we look at the slides, it starts usually with the general GIS slides, GIS slide. So what are we doing with the GIS? We're organizing the world's geographic knowledge, starting with the data, obviously, as a center, having different data models, workflow, analytic models, and then obviously also really important to present the data in a meaningful way using maps and visualization techniques, and also telling the story of your data in kind of map series like story maps or creating reports. So this for GIS in general. And if we then talk about a platform, a GIS platform like our ArcGIS platform, we use often the term that this is geospatial infrastructure. And geospatial infrastructure is kind of what we call the modern GIS implementation pattern, where it's service-based architecture. So you can engage everyone by sharing and collaborating on your data. So you can work as an individual, of course, but you can also then use the service-based infrastructure to work in teams, departments, organizations, and communities. And your GIS platform scales in this regard, then depending on the size you need it. And if we take a look at the technologies, now we're getting into kind of where I wanted to first highlight our topic of today, because we have a different technologies outlined here, starting from integration into an existing enterprise architecture, the shared services I mentioned, open access, but then also in the center here, sensors, IoT, and one big technology or one big application use case of this one is, of course, real-time tracking. And then also some newer technologies like GeoAI and machine learning, advanced spatial analysis. And if we look at the capabilities, here it becomes even more clear how important or the real-time IoT services or the real-time data streams and the integration is a key part of the capabilities we have with this geospatial infrastructure or the GIS platform, because it's one separate highlight is highlighted here in the bottom next to all the other capabilities. Tracking is also a piece of it, big data, data science, and so on. And this becomes finally also clear if Jack talks about kind of the three fundamental systems of a GIS, where we have the system of insights, so our analytic capabilities. We have the system of engagement, so working with the apps and maps kind of in the community, and the system of record, which is kind of storing all the data. And there in between, he even highlights kind of our real-time measurements, so our sensing data, being it from the field as IoT devices or from remote sensing. So this is just to highlight again how important this topic of this conference in general is, and therefore I'm kind of really happy to talk to you about this. Because it's a really important aspect of a GIS nowadays. Okay, so if we talk about sensor data streams, we often talk about IoT, and I first want to kind of give a more technical overview and a blueprint kind of in slides, how we can use different components from our ArcGIS platform as in the context of IoT, and then want to show you a few live demonstrations, because I thought in the beginning about how can we make this even maybe more interactive, because it's called a tutorial, but it really doesn't make sense, in 90 minutes give you all individual hands-on experience. So I'll dive into some demos later on, and as I said in the beginning, please feel free to ask questions in between. Okay, so if we talk about the IoT, we of course have a bunch of different application areas, reaching from maybe transit to energy usage, to utilities, airports, weather. So we have basically application areas of sensor data streams everywhere. And it really depends what kind of your use case is in this regard. And if we talk about what things play a role, this is also kind of all different kind of sensors, from tracking devices to environmental sensors to different model outputs. So we have all kind of different sensors out there. And why do we think that a GIS is a good platform to analyze or manage all your IoT devices? It's because most of these things, or nearly all of these things, have a location associated with them. So I think there was a study a few years back where it says like 80% of all data has a direct or indirect location attribute. But if we talk about IoT sensors, then really most of them have this, and therefore a GIS system is a really good system to manage and kind of analyze the data. So if we talk about a IoT platform more in general and talk about a blueprint, we can roughly divide it into 3 sections. We have on the left-hand side the edge, where our sensors are sitting on devices in the environment, so our things, and they generate sensor data streams. And on the IoT platform in the center, we then have different capabilities that we need to work with the sensor data streams. So we first need some solution to ingest the data. We we want to perform then real-time analytics, so streaming analytics on the data. And from this streaming analytics, we want to derive kind of some actions or intelligence that can then be used. We also want to store the data to have it persistent somehow, and then use maybe a bit more sophisticated batch analysis on the stored observation to detect patterns in space and time, and therefore also deriving kind of some intelligence and generating some actions from this analysis. And finally, we want to then use these insights we gained from the IoT platform in our applications in the enterprise section on the right-hand side, where we have different applications, being it in the web, on mobile devices, or on the desktop, to work with this data. So the main kind of capabilities we need is ingestion, then the real-time data streams as kind of as alerting. So as soon as something happens where you maybe define a threshold for some attribute value or so, you want to be notified about this. And of course, analysis in general on the IoT platform side, and then the visualization piece on the right-hand side of the enterprise. if we now look how our ArcGIS components can fit in this diagram, we have ArcGIS Enterprise as our platform on-premise, being for the user and content management. We have then the GeoEvent Server for the real-time processing of the data. We have the Spatiotemporal Big Data Store as a storage solution, which was specifically designed to store large amounts of sensor data and being efficient and working kind of with larger data amounts. And we have the GeoAnalytics Server, which is also analytic server component designed to handle larger data amounts for the batch analysis piece. And these are more or less the components I wanna talk to you a bit about more in detail today. What we also, of course, then have on the enterprise side is a bunch of different apps. I don't even have an idea how many these are by now, but there is almost an app for kind of any use case. Yeah, there you can visualize and work with the data effectively. What we don't have as part of an IoT platform with our products is kind of the device management solution. So Esri or ArcGIS doesn't provide any capabilities in this direction, and therefore we usually deploy our platform next to an existing IoT platform where you then often have some form of a gateway aggregating kind of all the sensor devices. And if we take, for example, the Microsoft Azure IoT platform here, we have as a gateway the Azure IoT Hub, where then the GeoEvent Server component can directly integrate the data from the IoT Hub instead of the individual devices. We have then for the device management, obviously the required solutions on the Azure IoT platform. And we can also combine kind of our analytic capabilities with different capabilities from the existing IoT platform. So for example, the function app, we can use the Azure Blob Storage, Stream Analytics, and so on here as well. And of course, on the right-hand side, on the enterprise side, we can also use then apps that are from the IoT platform to work on the geospatial data or the results of our analysis from the IoT platform. So basically, if I want to position kind of our GIS capabilities here, we basically extend IoT platforms with the spatiotemporal analysis capabilities via our ArcGIS platform. Okay, this should be enough theory, or I'm going to start with the GeoEvent Server next, but quickly going to dive into a demo. But if we have already some questions by now, let me just check in the chat. There's some. Oh, okay. No, that was just Mattis saying that he's monitoring the chat. Okay, so no questions so far. So then we continue with the GeoEvent Server, but I want to quickly jump into live demonstration instead of just showing you a bunch of slides. So let's briefly look at one introductory slide. So the GeoEvent Server is basically what we call a optional or functional server component to ArcGIS Enterprise, and therefore it extends ArcGIS Enterprise, so the general GIS platform with the capability to have real-time analytics capability here. And it is closely associated with the Spatiotemporal Big Data Store, because that was kind of in the historic development of our products. We first had the GeoEvent Server integrating all the sensor data, and then quickly it became obvious that we need some new solution or some new kind of data store to efficiently handle all the large data amounts we can collect with the GeoEvent Server. And therefore the Spatiotemporal Big Data Store was developed soon after the release of GeoEvent Server to have kind of this component to handle large data streams. But I will get into a little bit more detail on this later on as well. So the GeoEvent server, from the capability point of view, it can cover the required capabilities of the ingestion, so integrating sensor data. We can then perform real-time analysis here on the data. In combination with the spatiotemporal data store, we can also store it efficiently. And then obviously use ArcGIS Enterprise to visualize the data. And what is also one important aspect is we can also communicate back from the GeoEvent server outside the GIS platform. It's here termed as actuation in terms of the IoT device specifically, but in general, it's important to note that we can just, communicate and also notify external kind of applications. Also, for example, sending a text message or sending an email or something like this. Okay, and before I get into more slides, I'm just going to jump into a demo. Let me see if that works. Where's the web browser tab? Here we go. Okay, that looks good. So I want to show you kind of how we can, or on one example, how we can integrate sensor data streams using the GeoEvent server into the ArcGIS platform. And I'm starting here on a blank interface kind of the so-called GeoEvent Manager, which is a web application to manage kind of the inputs. Oh, I just saw that Michael posted that the sound quality is not that good. I'm just gonna yeah, if it's okay for you guys, I stop the video and also stop the synchronization of OneDrive. I forgot this, sorry about that, and I hope it's getting better now. Okay, so we're here at the GeoEvent Manager, the web application to kind of manage your real-time analytics and also the integration of sensor data streams. And here we for those of you who have already worked with the GeoEvent Manager, you probably noticed some difference to prior versions here because there was a lot of work going into the UI and the usability of the product, make it easier to use. So what we see here is already the three main components on the start page. We have GeoEvent services, which is kind of designing the workflow of real-time analytics, and we're going to see this in a second. And we have inputs and outputs, and these are already the three main components, so to speak. The inputs for integrating data, outputs for sending out data, and the GeoEvent services to combine these two. What is new now, we can kind of design everything out of a GeoEvent service. So if I create a new service and we're gonna work with data from the open data portal of Münster. So just gonna call this Münster Busradar and create a new service. Then you can see, once this is loading, that we now can basically create everything in this canvas, which is a workflow or a model builder like experience where we can create inputs, outputs, and filter and processors respectively. And I want to do this example on as I said, API from the Open Data Portal Münster, from the Stadtwerke Münster, which have a real-time bus position or live bus position feed here, which originated from the Münster Hack 2019. And I think Dennis Wilhelm from Conterra is also having a flash talk on this tomorrow. So if you're interested in how to build such an API for real-time transit data, please join his flash talk tomorrow. And here we have as endpoints kind of for the API, one example here for the real-time bus positions. And if I open this in a new tab or in a tab, we see that we here have a REST endpoint where we get presented with a feature collection of kind of the current bus positions, including the property values, and we see that this is in the GeoJSON format. So what we want to do to integrate kind of this real-time data now is polling this endpoint frequently with the GeoEvent server to always get the latest position in our GIS platform integrated. So I'm just going to copy this URL here. And if I go back to our service, I can just drag a new input on the canvas. And here we now get presented with an overview of existing kind of input connectors that we have. We have a few, or in general, I want to differentiate here between connectors that are available out of the box. So these are the standard connectors. And then we have also the possibility to extend the GeoEvent server by so-called custom components, but I'm gonna get into this a little bit later, where we are working currently on a input connector for polling the Sense of Things API for JSON. But in this case, we saw that we have a GeoJSON REST endpoint. So we want to poll an external website for GeoJSON. And if I select this one, I can specify a few attributes of this connector. So I have to give it a name and just gonna call it was the MS GeoJSON pollen. I'm going to specify the URL that I just copied. And then I can have GeoEvent Server create a GeoEvent definition for the data. And the GeoEvent definition is basically a description of the schema of the data. And we're going to see how this looks like in a bit as well. Just going to call it now. Okay, MS pollen, and the method is get. I could specify some more advanced parameters here, starting from kind of the frequency or receive new data only based on some header parameters, and so on. But for now, I'm happy here polling the endpoint every 5 seconds. And if I save this one, and then this input is dragged onto my canvas here. And I can, for now, just use a dummy output to be able to publish this GeoEvent service, because I need an input and output to publish. And if I connect these two and hit publish, then my service becomes from unavailable as marked as started and is now ready to process kind of my real-time data. What we also integrated way to inspect the data right when you design kind of your analytic workflow. So if I start this one now, the input, I see, okay, we're polling 117 bus positions right now in Münster. And I can now sample kind of routes between components in my GeoEvent service. And then the sampler utility here at the bottom pops up, and I get an example kind of the data that is processed here. And I see, okay, all of the attributes that I expect are in here as well. I also have a geometry field from the GeoJSON that seems to be interpreted correctly, but if I want to double check this, we also have a event viewer in here, which allows you to display the sample data kind of directly on a map. And here we can just verify, okay, that looks correct. It's in and around Münster, the data. So this seems to be fine. And we can keep on working with this data if we're happy with it. One thing though, which I meant to show you, which I okay, it's not displayed here, but if we would look now at this data on a map, we would see that the timestamps, because they are in seconds and not in milliseconds. For example, this one, the Abfahrtsstart, or the current timestamp, which is this guy, that they are in the second format and not milliseconds, and GeoEvent would need kind of the millisecond format to interpret this correctly. So then we can start working on the data and put in different processors or filters. And I've already created one service to make it a bit quicker beforehand. So if I go back to the manager page, here I already have my previously created service, where I, to start with, kind of integrated a couple of these field calculators. So if I would drag a new processor on here, I get also presented with kind of an UI where I can, from this drop down, choose different processors, and these are ranging from very GIS specific processors working on our spatial data, like a buffer creator or also a geotagger. But then there are also processors working just on the attribute data, like the field calculator that I used here. And if we look at one of these, I can just say, okay, I want to use my attribute, multiply it with 1,000 and save it in this existing field again. So I just multiply the 3 time fields in the data stream with 1,000. So I have the correct time displayed, and then put the data out into an archive where I can store the data in the Spatiotemporal big data store. This, however, is kind of just the data preparation. If we now want to perform some analysis on the data, we can use kind of a specific concept we use in the GeoEvent server to perform real-time spatial analysis. And this concept is called, or we call them geofences, which are basically more or less just geometries of interest that you can load into the memory of the GeoEvent server. So you can perform kind of efficiently real-time analysis against these geometry of interest. And if we look at the geofences, what I have done here, I imported for each line kind of a geometry where I buffered the GTFS line component by a few meters. So, for example, we can perform analysis now if a bus is not on its assigned route. So if it leaves the assigned route, we can detect this by performing an analysis on these geometries. And here's also as well, for the geofences, we integrated some nice utility to visualize kind of your geofences right away. So here I can see for the line, which one did I click on? E17. Okay, let's not do one of the E's. Let's do this one, for example. We have the geometry then here displayed in this geofence view, and we can verify, okay, this is I mean, it looks correct. It's in Münster. It's for this line, the usual route that the bus would take. And now we can use this geometry in the memory of the GeoEvent server to perform real-time spatial analysis against this data stream. And therefore, I have created an incident detector, which is one of the processors available out of the box. And here we can then specify kind of an opening condition on which we want to have an incident created. So in this case, I just say, okay, for my incoming events, so the bus position, if the geometry is outside any of these geofences, and more specifically, not only in general the bus radar geofence, but the geofence associated with the line ID that the event has. Because of course I don't want to know if line 5 is outside of the geofence of line 17. I just want to know the respective geofence, and I can specify this here using attribute values from the incoming events. And if this is the case, we want to create an incident as a warning and have this then put out to a different output. And now I just realized that I forgot to open the application where I want to show you how this actually looks like. So let me just quickly open this. Okay, so what I did here is I created a dashboard using kind of this analysis. to display the kind of lines that are currently not on their assigned route. And let's see if we have a nice example here. Okay, this is just not accurate enough. Let's see. Okay, this one is also not going, but yeah, we don't have a nice example now, unfortunately. But we had some interesting cases, and I can show you a video later on otherwise, where we had kind of bus positions not following the assigned route because there was oh, I don't even know how to explain this in English, but a Falschparker. So if a car was parked and was not letting kind of the buses or allow the bus to pass the normal way because there was a car in the way which was parked incorrectly, then we had some notifications that the buses had to go on a different route. And we can verify this kind of with displaying the information for the stops on the left hand side, on the right hand side here. So if I zoom in, which is also a nice feature of this app, and click on one of the bus stations, we can see here which buses are supposed to come, and they also display kind of real-time information. So if we, for example, also have, unfortunately, it's not Wednesday right now, where there is a market on the in the center of Münster, and then the buses who are usually going here, like you see right now, have to take a different way, then this would also be displayed here, and we would also get the warning kind of a bus that is going in this direction. Maybe if we have time at the end, I can show you the short video we recorded here where this is the case. And but I think you get the idea that we can kind of identify where buses are not going the correct way. For example, this one now is outside of its assigned busway or bus line, and I think it's hard to verify right here why it's not going this way. Maybe it's just turning around here. But yeah, this is some example of spatial analysis we could take, and then also an example of how we can visualize this this data in a dashboard, for example, where we have a map-centric application using other components for real-time information as widgets. Okay. Yeah, that's kind of what I wanted to show you first for as an example how we can integrate data streams using the GeoEvent server. What I also mentioned is that we can extend, or let me first jump back to the slides to catch up with the slides on what we've seen so far. So we have seen that we can do ingestion with so-called input connectors, and we have a bunch of connectors out of the box available. It's mainly a combination of yeah, it's basically some industry standards in terms of the transport, which is the mechanism like HTTP, POL, TCP socket connection, UDP socket connection, and WebSocket connection, and then different file or formats like GeoJSON, JSON, XML, and so on that we can combine. So these are the out-of-the-box components. Then we have also galleries where we have some connectors available to extend these, and also galleries from partner. For the Esri galleries, the components are available or the source code is available on GitHub. So if you ever want to develop your own connector and need a starting point, I would recommend to check out what's on GitHub there and get familiar with kind of some example code or extend one of the existing connectors from GitHub. And similar, it's valid for the output. Or for the actuation here, we have output connectors out of the box, which can be extended via the gallery. And yeah, I already mentioned this. If that all doesn't fit kind of the need, we have a software development kit for the GeoEvent server where you can create your own connectors using this SDK. So for process and filters, what we just saw is kind of that we have a as well out of the box components, and also here is valid that we have a gallery, and if you want to incorporate your own processing logic even, and then you can also create own processors using the software development kit. So we basically can extend the GeoEvent servers to, in all regards, on the input side, on the output side, and also on the processing side. And to do spatial processing, I briefly showed you the geofence concept, where we can, for example, detect if objects inside or outside of a geofence, like with the buses on there, assigned bus routes. But this geofence can be more than just polygons. It can be lines, points, and we can do different or can use different operators on them, like disjoint, contains, crosses, like you see here. One specific operator, or two specific operators I want to point out, is enter and exit, because if we want to detect if an object enters or exits a geofence, we obviously need to know where this object was in the previous observation. So if an object was before outside the geofence, is now inside the geofence, this obviously means that it has entered the geofence, and therefore we call this stateful processors, because they keep the state of the previous observation of the object in memory as well. Yeah, so this is kind of the theory behind what I tried to show you in the short demonstration. Maybe a quick side note on the visualization aspect. What we can do here, we have two different ways kind of to visualize real-time data streams. So the, I would say, kind of regular way is to write the data obviously into some form of database, and then client application that want to visualize the data are frequently polling kind of this database to get the latest status of the data. And in our case, this data can be written to the Spatiotemporal data store or any enterprise geodatabase. And the benefit you have here is obviously that you can also play back kind of the historic values of the data, because the data is just persistent in this database. The downside, though, is that you are dependent on refresh intervals, because obviously GeoEvent is pushing the data to the database in a certain interval, and then the client is querying this data also on a given refresh interval. So you have kind of a little lag in time here. And therefore, we also introduced a different type of layer a few years back, which are stream layers. And stream layers are kind of using WebSocket technology under the hood. And instead of having this polling interval on the right-hand side, the GeoEvent server is pushing the data streams to the client applications right away, and data is visualized immediately. So there are kind of these two patterns that you can keep in mind, and it really depends on the use case, which is preferable to use. In reality, it's often combined. So because the stream servers don't persist the data, you usually combine them with a feature service in a geodatabase, and this way visualize the data as soon as it arrives via the streaming component, and having it persist in the feature layer, which can be coupled or can be used in a combined way in your application. Okay. Originally, I intended to start here with the demo, but I thought I don't want to show too much slides before. So we have done this already, and when briefly mentioned now that we can extend the GeoEvent server using the software development kit, which is in Java, and for automation purpose, we also have an admin REST API, which is documented with Swagger. And speaking of extending GeoEvent Server, I'm gonna switch back to my application, to my browser here, because I mentioned in the beginning that we are currently working on a different connector for the Sensor Things API, and we do this together with the LGV of the city of Hamburg. which are or which have already implemented a Sensor Things API to have a standardized kind of interface to IoT sensor data. And if we just take a look at this, this is how how this OGC standardization of sensor things looks like. We have different REST endpoints here. For example, our things that we can take a look at. Here are different things that are displayed, like, for example, renting stations from bikes in Hamburg. And if we want to use this kind of to query data about the status of this bike renting stations, meaning how many free bikes are available at each station, we can do this via, for example, the observations. And here you have the possibility to construct you are really flexible in constructing different queries. You can apply filter, you can extend certain aspects, and then end up with a more complex query like this one, like you see up here, which I use to kind of filter the observation for only data from these bike renting station from the Deutsche Bahn Rent, and include kind of the geometry of these features. And now similar to the bus positions, I can poll this endpoint frequently with the GeoEvent server to kind of get always the latest status of this data. But what we noticed when we did our first proof of concept is that we need a custom component here, because GeoEvent, for example, doesn't like the dot notation in the field names. So we needed to create a really simple custom component that is replacing this one. And we also thought about, okay, how can we only query the latest features? And therefore, we integrated capability, and I'm going to show you this in the GeoEvent Manager. We created the capability for this input connector that allows us to specify the last polling date time. So I have under the URL attribute here, I have this query that I just showed you in here. And further down, that's here. I can use now kind of replace a part of the URL string with the last polling date. So we enhance kind of the standard connector to remember the timestamp when it last polled the data from the API, and then use this one in the URL string to be able to filter the data in the Sensor Things API to only display data that has that is basically updated since we last polled it, and because we don't want to overload kind of both sides, the Sensor Things API and GeoEvent with querying unnecessary data, right? So this is an example how we use the GeoEvent Server SDK to extend or to modify an existing component to our needs. And what we can do now with this is kind of we can also create a GeoEvent service polling this data every so often, and then I had do some adjustment to the data in terms of a field mapper, where I modify the schema from being a nested JSON into a flat JSON, because in the GIS system we only use the flat JSON structure, and also calculate the geometry afterwards after I have it in a flat structure, and then put this out onto into a service in the Spatiotemporal data store. And this then just looks like this, where we now get all the latest status of kind of the bike rental stations in Hamburg in real time directly from the Sensor Things API. So this should just be a short example on how we can use, and I think I visualized this. So as soon as here are 12 bikes free, as soon as there are more than 5, it's green. Otherwise, the red ones, they should be all used right now. So yeah, this was just a short example how we can extend or modify kind of components from the GeoEvent server. Okay, then let's jump back to the slides. Yeah, I'll definitely share the slides afterwards. So I put in a few resources in here. The product development team also worked kind of on the documentation of GeoEvent to make it easier to get started. So there's a whole new documentation or update documentation on this URL. We have a quick start guide and a few tutorials to get started. So really in the last couple of years, the development was focused on making this product easier to use. And yeah, I would be happy if you are interested in this technology, just give it a go. And if you have questions, feel free to reach out to me. Speaking of questions, before I move on, I'm just going to check if there's anything in the chat. Not so far. Okay. Please really, if you have questions, just put them in there right away. And otherwise, we're gonna continue with the spatiotemporal big data store. So the spatiotemporal big data store, as I said, is kind of, from a historic point of view, developed to handle all those large data amounts we gather from the IoT sensors or from the sensor data streams we integrate with the GeoEvent server. And it's specific, or it's kind of a different kind of database, because we use a non-relational database under the hood, which is Elasticsearch, for better performance, which can also be deployed in a distributed fashion as a cluster, and allows for replication of data among different nodes. But the most important thing is that due to the non-relational nature, we can create different indices, one for or one spatial index, a temporal index, and Elasticsearch is usually a search engine which works really well already on kind of attribute basis. So we have these 3 dimensions which we all have indices for, and therefore can perform really performant queries on the data. We can also use the spatial index to perform some on-the-fly aggregation in the visualization piece. So, for example, this data on the right-hand side, it's I think over 20 million points, which doesn't make sense to display as points on the map, but we can use it in an aggregated fashion, like you see here. And once we zoom into a certain area, we can then switch based on a threshold between the aggregated view and the individual feature view. And there are some, I'm just going to skip the video because I have a live demonstration for this one, because there's also a new feature for this. So let me switch back to the browser. And if I go to a different tab here, I have the archive data from the GeoEvent server. And if I enable this layer, you see, I hope you see how slowly this draws, because it's not, I haven't had this run for a long time, but we already have around, let's see if I check this, we already have a bunch of features in this archive from the bus position. So it's almost 1.5 million by now, and obviously 1.5 million points on the map. It's, yeah, if you have worked with larger data in ArcGIS, you're familiar with this symbol, that not all the data can be displayed. It's slow. It doesn't make sense to put so many features on a map. And therefore, we can use this aggregation capability of the spatiotemporal big data store to create a kind of aggregated map service of the data, which then can look like, I hope this loads now, can look like this. And the cool thing about this one is that we now can design, and you can judge from this visualization that I'm really poor in designing appealing maps, but we can design this map services in ArcGIS Pro. So if I have ArcGIS Pro open here, and I'm just going to add this feature service from my spatiotemporal big data store to the map, it will automatically display in this aggregated way. And I can now see that I have here the possibility to specify 2 renderers for being it features or the aggregated bins. And if I choose this layer, I have also a new binning tab up here where I can specify, do I want to use the binning, yes or no? Otherwise, it would display the individual features again. I can select the threshold, either being it on a scale basis or on a per feature basis, where I want to switch from the aggregated view to the individual feature view. I can specify the bin size, so maybe make this one a little bit smaller for this extent. I have the different spatial indices available here, or the spatial aggregation from hexagon, pointy or flat, to square and geohash. Under the hood, it's all based on geohash, and these are derived from the geohashes. And I can also do some easy statistics on this ones. For example, here, if I want to not only have the count as an attribute available, but want to maybe use the delay of the buses and do the average delay, I can also specify this one, and it will calculate in the background now the average delay for each bin. And now I can, really go in here and symbolize the data as I wish. So if I go for the bins, I can do unclassed color symbolization based, and now it calculates or computes the stats for these bins. And now I can use either the count shape or my mean delay that I showed before, and play around here and do some nicer visualizations using the spatial index of kind of the spatiotemporal big data store here. The result that I showed you before is kind of here, where I also can add labels to it. I use the squares in this case, and then I can publish this layer as a map service to my enterprise portal. So on here, I can now, which is also new under sharing, publish a map service layer based on a feature layer. And this then, or therefore then, the map service uses the data directly from the spatiotemporal data store in this way here in the web map, like you've seen here. And this obviously makes way more sense to display the data in this fashion. If I now zoom in, the bins will adjust also in size, and I believe I had as a standard threshold set that the aggregation or the view switches on a certain scale. So once I zoom in close enough, I can also get back to the individual observations, and the other way around, toggle again the aggregated view once I zoom out. So this is really nice way to work with larger data amounts in the map service, which is way better than putting all the individual features on a map, because you also have to keep in mind that the feature view is kind of rendered client side, whereas this map service is generated server side. So you can take a lot of load from the client by serving it out as a map service. Okay, so this or so much to the spatiotemporal big data store. Let's go back to the slides briefly. Okay, that was a video. Yep, that's what I just showed you. So next, obviously, from a historic development point of view, again, we then had to ask ourselves the question: okay, how can we now make use of all the large data amounts we store in the spatiotemporal data store? And therefore, a new analytic component, the ArcGIS GeoAnalytics Server, was developed, which is designed to efficiently analyze kind of larger data amounts and also work with existing enterprise data. And I just briefly want to introduce it with a few slides. So basically, what is GeoAnalytics? It's a way or a new framework, and we use Apache Spark under the hood here to parallelize compute and therefore more efficiently or quickly analyze kind of vector and tabular data. And it's providing a collection of analysis tools, which are mainly there to kind of identify patterns, relationships, anomalies, and incidents over these larger data amounts or across space and time. So that's basically what GeoAnalytics provides. And I always liked to show this and draw back kind of to the IoT capability needs that we discussed earlier. So now with this component in place, we have the complete picture of streaming analysis, data storage, and batch analysis in this architecture to be able to handle the IoT use cases efficiently. And to give you a bit more detailed overview, I'm not going to go into each tool in detail here, which the GeoAnalytics server provides, but what's important to note is that they work in both dimensions, so they are spatial and temporal, and the main tools are to analyze patterns or to summarize the data. Of course, also manage data is important, but in the spatial analysis domain, it's to summarize or analyze patterns, because you want to from the large data amounts derive kind of smaller insights, so only the patterns that are relevant to you, or aggregate the data in some way by summarizing it. And one example here is aggregate points. And I just realized that I forgot to translate this slide. But anyways, it's kind of just to highlight that both dimensions are important. If we look at the upper picture, we can aggregate kind of points into areas of interest and polygons of interest, or we can also aggregate them like in the lower picture in regular grids, which is only dealing with the spatial dimension. And what's really important is that we provide both kind of the spatial and temporal dimension here to create kind of like time slides of the polygons or space time cubes in the case of a regular grid, to work with spatiotemporal data. Same for another interesting tool, which is join features, where we and that's more or less one of the key capabilities of the GIS in general, right? That we can combine different data sets, which are usually not or don't share a common attribute and don't have anything in common but their spatial location. And we can combine them by using spatial analysis over space and time, of course. But that was enough on the slides. I'm going to jump back to the browser and show you how we can use actually this GeoAnalytics capabilities in here. So we have the capability to or we can start analysis in different ways. We can start them here from the enterprise portal. You could also start them from ArcGIS Pro or via the REST API. But if I just going to show you a quick example here. For example, for feature analysis, I can then choose my GeoAnalytics tools, and I'll be displayed with all different analysis that you saw on the slides as well in the different categories. And in this case, if I want to, for example, aggregate this 1.5 million points to make more use of it, I can, for example, reconstruct the tracks of the bus positions. So I want to reconstruct the tracks based on where's the correct the Fahrtbezeichnung, so the ID for the unique route kind of driven. And if I want to use this one, I can then say, okay, I want to aggregate all points that belong to the same journey, and just to make sure that if this ID would be used twice, I can also split kind of the tracks if there's a certain distance between the next observation, or if there's a time between the next observation. So I can say, okay, if there are 5 minutes in between some observation, this must be a new journey. So I want to split them there, and then add statistics to it. So in our case, for example, if I want to see on which routes is usually a delay, I can use delay here and do some basic statistics on this attribute. For example, here the mean for the delay, and then I could just start this analysis here. I've done this already in the interest of time before. So if I go back to my layers, I have here the reconstructed tracks, for example, for my bus journeys, and I visualize them based on based on the average delay. And if we now step through time, because that's obviously also important if we talk about the space-time analysis, also the results are time enabled, so we can use things like a time slider here to step through the data, and then I can see, okay, on which line to which at which point in time, for example, were the buses and on average more delayed than on others, but in general, in Münster, this looks pretty good compared to Cologne, where I live. It's probably that would be all red. But yeah, we have at certain time, mainly obviously also in the peak hours in the afternoon, we have some more delays, and this way you can easily detect kind of or get some first insights based on the aggregation. And here I had the machine turned off, so there's no data. So let's jump back here. But yeah, this was just one example for the kind of aggregation analysis where then I have less features obviously than the individual points and can work with this aggregated data set being the journeys further on. And another example is that if I want to detect some patterns or just get some insight of my data and create smaller data sets that are of interest to me, I could, for example, use find locations as well, where I have this detect incidents, which is similar to the incident detector we saw on the GeoEvent server before, where I want to detect an incident if a bus leaves its assigned route. But in this case, we can do this on all the stored observation, not on the event data. And I want to show you this one, where we then would obviously say kind of, okay, I need the ID again from my vehicle. But here now I can build an expression, and this expression can be really powerful because we can use an expression language called Arcade. So Arcade is basically an expression language that can be used across the ArcGIS platform, which allows us to use different functions. I click here on the function reference, from data functions to date functions, geometry functions, logical, mathematical, and text functions, to construct really more complex expressions. And in the special case of GeoAnalytics, we can even use a time sliding window, so to speak, over the data. And we use this to create an expression like this one, for example, where we can then use this it's called track field window, to determine kind of, okay, we don't want to have the delay field empty. And then we say, if our current delay is larger than the previous delay, we use this track field window to access the previous value again, plus 90 seconds. So basically, if we have a change in delay for over 90 seconds between observations, and some additional conditions, we want to classify this one as an incident, and then we can paste this expression in here, return only the incident features. And I've also done this before, and then we can, from this 1.5, I ran this just this morning, so it was like 1.4 something million observations. we can drill this down to a really small number of observations where kind of the delay changed by over 90 seconds from one observation to the next one. And there we can see, okay, that in which places in Münster, obviously around the main station, where's the central hub for the buses, but also here in the old town and down here at this crossing, there's usually some places where the delay primarily occurs. Okay. Yeah, this was just an example for some analysis with the GeoAnalytics server. What we also can do, we can, since this one is based on Spark, we have the possibility to scale this analysis capability over multiple machines. We can connect to external data sources, and therefore we integrated a concept of big data file shares, which is basically a reference data source. So we can read kind of from file shares, from HDFS, from Hive, and from different cloud storages, data directly in the following formats: delimited files, shape files, Paschke files, and ORC files. So we can use these files directly for as input for our spatial analysis, and we don't need to copy the data before kind of into a geodatabase of any kind. But we can directly read from these input possibilities. And for the output sides, the standard output would obviously be that the data is written to a hosted feature layer. But if you, for one of your use cases, maybe don't want to display the data, or the geo analysis piece is only an intermediate step in a longer processing chain, we can also write back the data to a big data file share, meaning we can also write the results back as, for example, CSV or a Paschke file. And sorry, and this really allows you to integrate kind of the geo analysis component also in more complex workflows. Or maybe if like I showed in the beginning in the IoT blueprint, or that you can also then use other apps, for example, the Azure Function app on this results of a GeoAnalytic analysis and so on. So this gives you more flexibility here. And the next piece I want to show you, or which is also really interesting from my point of view, is that we also enable you to use the underlying Spark framework by the use of PySpark. So with PySpark, you can then make use of kind of the Spark framework itself, and also libraries like the machine learning library from Spark MLlib that comes with Spark to integrate these into your analysis workflow, and obviously also to pipeline analysis. But before I show you a demo of this, I want to, oh no, I'm just going to switch to the browser first, and then I show you the next slide. So if we want to perform an analysis like this, I'm just going to jump now to a different scenario. We're not in Münster anymore. We're in Berlin, where I have current positions of the regional train traffic kind of here on the map, and I also stored these observations to be able to perform analysis on them. So I stored them as a CSV and used then a big data file share to analyze this data. And if we want to use now GeoAnalytics with PySpark, we can integrate this one into what we call ArcGIS notebooks, which are basically an implementation of Jupyter notebooks, and that's the next slide I want to show you, but I'm going to go into more detail in a second here. It's an implementation of Jupyter, which makes or opens really a lot of possibilities to work with your GIS data in the context of the whole Python ecosystem. So you can use all different kind of open source Python libraries to work on your data that is in your GIS platform. And in our case, I just have a quick example that I'm going to show you where I want to analyze the stored observations from the strain positions that you saw a second ago, and therefore I can easily access kind of data in my GIS platform using Python in these ArcGIS notebooks. And it's as easy as I have this reference here, but we also have a UI implementation around the Jupyter notebooks where I could, for example, now search for layers and click just the plus button, for example, on the detected track incidents I used before, and would be referenced here directly in the Python code as an item. And then I can work on this data, for example. In this case, what I did here is that I used the big data file share, and in there is a layer with VBB. It's for Verkehrsbund Berlin-Brandenburg, which has the stored observation as CSV registered. And now I can use I can define my my Python script containing commands from PySpark here as a function. So I can import here different libraries from PySpark, ML, for example. In this case, I first created an incident, or I used an incident detector to do a similar analysis that I showed you in Münster, where I want to detect kind of where the delay occurs in these positions. And then I want to use some native PySpark or Spark machine learning libraries to cluster these observations. And yeah, this can be done by just using these packages in here, and we can combine them then with our GeoAnalytic packages, which are already automatically imported into this framework. So we can here really combine both our spatial analysis tools and the native Spark machine learning functionality. And then I can just use the run Python script method to pass in the script as the code, and my layers that I selected previously as my input layers, and it will run this code using the Spark framework, which you can see on the distributed task it completes, and puts out a layer eventually, which I have also opened here. And it's from the application now, it's maybe not the most useful one. It's just a showcase, or should just show how we can kind of use these two worlds together. So we have all the incidents over a larger time span here. It's 5 days in October 2019 that I had stored on CSV, and then I can first detect all the incidents and then apply a spatial clustering algorithm on them. Okay, so that was just an example for this one. And what I really hinted at or want to get at is that this is kind of a possibility to extend GeoAnalytics, and also I want to show you the capabilities of the ArcGIS notebooks, because this is really a powerful way of scripting analysis, and also what we introduced now, which is brand new and which makes a lot of or is really beneficial, is that you can schedule notebooks. So we have a new task item up here where you can now create a task for those notebooks and, for example, define run every 10 minutes. You can pass in parameters as key value pairs, and then specify kind of, okay, beginning on this day, I want to have it run in the repeat type minute, hour, day, week, and so on, every 10 minutes, for example. And here I can obviously specify different intervals, and should end on a certain time, or it's never ending, and I can also, if I integrate some variables that are changing, I can update my notebook on completion so it stores it. This task scheduler can then be used to perform reoccurring analysis using these ArcGIS notebooks, which is a really cool capability from my point of view. And it really fits well also in the bigger picture if we talk about stream and batch analysis. But first, a few more details here. I mean, I basically talked over this already for the ArcGIS notebook. It's an integration of Jupyter, which allows an interactive scripting environment for Python. And it works really well with our platform. And that's why we integrated it, because we have a deep integration of Python in the ArcGIS platform via the ArcGIS API for Python and ArcPy. And therefore, the notebooks really sit in the intersection kind of between the ArcGIS platform and all the open source Python ecosystem libraries that are out there and can be used. And that really opens a lot of possibilities. Of course, also all the implementation of kind of deep learning, machine learning algorithms runs via the Python API in the background. So that's another scenario there. Okay, I showed you this one already. Here, just some more information. And what I just briefly wanted to discuss before I want to leave some time for questions is that now that I highlighted this before, that we have this real-time analysis component, we have the big data analysis component, and with this scheduling capability of notebooks, they can sit somewhere kind of in this range, right? We can use the geoanalytic tools to also perform, for example, near real-time analysis, right? So if we don't want an event-based real-time analysis, or if we don't need this, right, we can also have a notebook run every 2 minutes, 3 minutes, 4 minutes, 5 minutes, and do near real-time analysis, right? But also we can just schedule our geoanalytic tools to run once a day, once a week, once a month. And so basically kind of this scheduling capability just allows us to to go from real-time analysis with the GeoEvent Server to really batch analysis and everywhere in between, using scheduled notebooks, for example, which I'm a really big fan of. Yeah, I have a few more slides. Maybe I'm going to skip a few just to give you a brief outlook what we're working on right now, which is what you've seen now is kind of the real-time and big data analysis capabilities in ArcGIS Enterprise on the left-hand side here. And what we're working on now, or which is already available, is kind of analytics for IoT as a software as a service solution in ArcGIS Online. And there we basically bring this real-time and big data analysis capabilities to ArcGIS Online as software as a service, on a microservice-based architecture. It's already available in the US, and we're still waiting or working on getting it available in Europe as well. And here we basically can perform all these different combinations of real-time and big data analysis without hosting our own infrastructure, having it all as software as a service and scalable, because it's based on a microservice architecture, and we have kind of new item types which are feeds to integrate real-time data, then the real-time analytics and big data analytics. So if you're interested for your use case to use a software as a service offering for these capabilities, please feel free to reach out to me, and I can tell you as soon as this is available, and we can maybe do a proof of concept using this new architecture as software as a service. But that should be enough, because we only have 8 minutes left, and I want to save some time if there are some questions. So I would stop here.
Great, thanks Thomas for this nice presentation on the capabilities of the ArcGIS platform with IoT data. So are there any questions from the participants? Raise your hands or write in the chat, and then I can unmute you. So Thomas, one question arrived in the chat regarding Python Cookbook and ArcGIS Enterprise. Oh, I have to unmute you, sorry. That's a little bit, here you go.
Yeah, it's weird because even if I mute myself,
Yes.
I can unmute myself again. Okay, the question was from Christoph. Could it be possible to show how to integrate the Python cookbook in ArcGIS Enterprise? What do you? Can you specify a bit more what you actually mean by the Python cookbook?
Okay, thank you very much. I just see that you show how to that you did explain how you can make some scripts with Python and to analyze the data on ArcGIS Enterprise. Did I understand right? Is it possible like this? That you can make Python script with the Python cookbook, or not cookbook, with the Python environment like Jupyter, and to integrate this in ArcGIS Enterprise?
Right. So basically, the ArcGIS notebooks are an integration, but you can also just use any kind of Python notebook to, in combination with the API for Python from ArcGIS to work with your GIS data kind of in a Python context.
Okay, and the Python notebook is already available in ArcGIS Enterprise. This, you don't have to have another component or something.
Oh, so the notebooks are available in ArcGIS Online now. In for enterprise, you would need the notebook server because it's based on a Docker container architecture behind the scenes, and you would need the notebook server to kind of host these Docker containers. But the standard license, which is the ArcGIS API for Python, is free. So you would need another server component, but it doesn't cost you anything.
So because we wanted to upgrade our ArcGIS Enterprise to 10.8.1 this autumn, and so it would be interesting to know if it would be possible to install to make an installation, right, to use this notebook server.
Yeah, definitely.
It is possible, and there's no license cost for this.
Right. So you should get the license. Yeah, you probably have to talk to your account manager that they enable it on my Esri, but then you can use. So the standard license is free, and you would just need a Linux server. I would recommend at least a Linux server for the notebook server because it's based on Docker,
okay,
right? Where you install it and then you can use it in enterprise.
Because this time we wanted to make an installation with ArcGIS Builder. This is we can use ArcGIS Builder to install this directly. Otherwise, you will ask the key account manager. But just because we right now prepare these installations, and I think this would be quite great possibility to analyze the data. So I just wanted to know, but it's already good to know that it's possible to install.
So basically, for the builder component, you would do or use this for the base deployment, and then the additional servers like GeoEvent, like Notebook Server, like GeoAnalytics Server, you can install afterwards, right? Once the enterprise base deployment is present.
Okay, that's good to know. Thank you very much.
You're welcome.
And we have another question from Sebastian Drost. You should have received yes, perfect.
Yes. Yeah, hi Tom. Thanks for your interesting talk. Several years ago, I was heavily working with the GeoEvent Server, so it was nice to see all the new features with this kind of application. I remember that there was a streaming layer support as an output, I think, from the GeoEvent server, so that you could integrate streaming layers within your own applications. And I think at this time, there was only the support for the ArcGIS JavaScript API. Has this changed after this year? Or?
Yeah, so they are implemented in different ways. So in enterprise, in the map viewer, it's implemented, but only with specific renderer types.
Okay.
But you can use them basically in a web map. In ArcGIS Pro, they're implemented for for 1.5 years now, and I believe in the SDK, in the different SDKs as well. But I'm not 100% sure if this has already happened or not. But yeah, you can basically use them in any web application. So also in the operations dashboard for visualization purpose only, right?
Yeah.
And also in web maps, but yeah, and also in ArcGIS Pro.
Okay. I think 2 years ago there was only support for the browser-based dashboard, and not for the desktop-based dashboard. Has it changed too?
But this fully went away. So there, the desktop-based dashboard is kind of not this, or is not continued anymore from the development point of view.
Oh, okay.
So it's fully JavaScript browser-based now, and there's also a new beta based on the new JavaScript API, which allows you also to use 3D data and so on in the dashboard.
Oh, okay. I see. Thank you.
You're welcome.
Thanks again, Thomas, for this very nice tutorial talk.
Yeah, thank you all for joining, and enjoy the conference.